Okay, there's a question on working with transformations, and since we haven't been in class for me to go over this, question was, how do I find, particularly with dilations, how do I find the center of dilation and the scale factor? So I'm going to do a quick recap of 29 and 30. Well, really just one of them. Let's look at 29. I think you'll be able to get 30 in your review packet for your semester exams. So first, to find the center of dilation, we worked backwards, and we had a center of dilation, and we did a problem where we had a center of dilation, and then you had to draw the other one. And so I think when we work through this, we're really just reversing that process. So what I'm going to do is I'm going to try to draw in the line connecting a pre-image and image point. And if I connect all of my corresponding pre-image and image points, those lines that contain both those points will intersect at the same point. So let me show you, or attempt to show you. So I'm going to first do a line, and I'll see how this works out. Okay, so I'm trying to do it through B and B prime, and I'm hoping this, I'm trying to work on my iPad right now, so bear with me because it's not letting me, whoops, I gotta drag that. Okay, so I want this to go through B and B prime, and it looks like that's pretty good right there. I'm trying to just be as exact as I can while still working on my silly iPad. Okay, so now I'm going to do a second line, and just for the sake of showing you what's going on, I want to do a different color. So let's see if I can do, let's change it to green. It would be a nice one we can see. This one I'm going to do through A and A prime. So I'm going to do a line through A and A prime. And you can already see it looks like those lines are intersecting right here at the point. I'm trying to find it. Let me highlight it with this pointer. -1, +1. So I believe that that's going to be my answer for my center of dilation. But what happens, which is really cool, is that it's actually all three lines will intersect. So just for emphasis, let's go ahead and do the last one. And I'm going to connect C and C prime with one more line here. Let's see what happens if I put this one. So if I make it go through C and C prime, and I want to do that. Oh, it's not letting me move the right thing. There we go. So what's happening is that that point that I pointed out a second ago, whoops, when I had my pointer on here, let me go to a different color. Sorry for all the clicks and the random pauses. That point right there is indeed my center of dilation, exactly where all three of my lines are passing through. So center of dilation, my answer for that would be -1, +1. And then and again, I think that if you reverse that, that was something that we looked at where we had the center of dilation, and then we tried to draw, and we actually drew the lines and then counted from there. And that's going to take us to the second part, which is find the scale factor. So if I'm looking for the scale factor, there's a couple ways I can do it. This one's situated nicely that I can actually just count. When I do a dilation, I create similar figures, and the scale factor is going to be the ratio between corresponding sides from one triangle to the next, or one quadrilateral to the next. So if I'm looking at my pre-image, AC is 2 units, and then if I count A prime, C prime, I'm getting 1, 2, 3, 4, 5, 6. So my scale factor is always going to be new image, the image over the pre-image, which would be 6 over 2, which is 3 over 1. Now I'm going to check one more side. Should be true for all of them. BC is 3 units, so B prime, C prime should be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm getting 9 also. So I'm getting 9 over, my original was 3, which is again 3 times is what we're figuring out. The new one is 3 times the original length. And then I could use distance formula, and I could certainly find the distance between A and B, and then A prime and B prime. And if I made a ratio, again, with some radical over some radical, that's going to reduce to 3 over 1, just like my other ones did. Okay, so you don't really need to do all of them because once you've done one, but it's always, of course, good to double check. So scale factor, I can't move it because everything's moving separately, but scale factor is going to be 3. Now, before I finish this video, let me just address what happens if there's not vertical and horizontal lines on my pre-image and image, because then I'm not going to be able to just count so nicely. And I did say you could do distance formula, and that would always work. But I think there's a little bit easier way to do it, and that has to do with just using your slope and counting the x and y components of your slope separately. So let me explain what I mean by that. If I'm going from my center of dilation, so this -1, +1, to B, and then I'm going to B prime, whatever my scale factor is, that's going to tell me how much further I have to go to get to B prime. So I'm actually going up 2 units to get from my center of dilation to B, and then over 3 units. So I could see how far I have to go to get from B to B prime, but I really want to compare it to how far do I have to go from my center of dilation to B prime. So I'm going to go from here, and I'm going to count up this time all the way till I would be going over and make this bigger triangle. And I'm going up 6 this time, and then over 9. And what I'm doing is I'm comparing my rise and I'm comparing my run. I'm not doing the slope because the slope is 2/3. I'm comparing how far did I have to go up to get to B prime versus how far did I go up to get to B, and that was 6 to 2. And there you're seeing again that ratio of 3. And then I had to go over 9 compared to over 3, and that's a ratio again of 3. So that's another way to get it. Hopefully that helps you understand dilations a little bit better. Try number 30. 30 is very similar. It's a quadrilateral, so you're going to have 4 lines instead of just 3, or you really don't need to draw all of them, but you should draw a couple. I usually like to do at least 3 because I need 2 for that point of intersection, but the third one should go right through that same point, and I'm double checking my work. Okay, hopefully that helps.